We look up and see this giant fireball in the sky, but the sun is so much more than that. It's this incredible cosmic engine, a place of ancient mystery, and it runs on a secret that we're really only just starting to wrap our heads around. So today, we're going to dive right into that secret, the amazing story of how the sun literally transforms matter into light.
But first, let me ask you something. Just think about the sunlight that's hitting your window or maybe warming your face right now. Now, you probably know it takes about 8 minutes for that light to travel from the sun all the way to Earth. But how old is the light itself? When did its incredible journey actually begin?
Well, the answer is pretty mind-blowing. The light that you're seeing right now is very likely older than all of human civilization. Yeah, you heard that right. The journey of that single particle of light, what we call a photon, started tens of thousands of years ago deep in the heart of the sun, fighting its way out through unimaginable chaos. This is the story of that epic journey. To really get it, we've got to go way back. Billions of years, actually. See, our sun didn't just pop into existence. It was born from this absolutely colossal cloud of gas and dust. Basically, the leftovers of ancient stars that lived, died, and then exploded, scattering all their atoms across the galaxy. So, in a very real way, our sun is made of recycled stardust. So, for millions of years, this cloud was just drifting. And then, a nearby star went supernova. That shockwave just ripped through the cloud, squeezing the gas and dust together. As these little pockets got denser and denser, gravity took over, pulling in more and more material. And right in the middle, this hot, dense knot began to form. That was the seed of our future star. Over millions of years, this protostar just kept growing, getting hotter and denser. As it collapsed, the pressure and the temperature inside that core just skyrocketed. It kept pulling in more gas, getting smaller, denser, and hotter until it finally hit this critical ignition point, 10 million degrees Celsius. And at this absolutely insane temperature, something fundamental changed. The immense pressure and the heat became so extreme that hydrogen atoms, the basic building blocks of the cloud, they started slamming into each other and actually fusing together. It's like a cosmic switch was flicked, and for the very first time, our star truly ignited. Now, the sun's core isn't really a gas anymore. It's plasma, the fourth state of matter. The conditions there are so extreme that electrons get ripped away from their atoms, creating this superheated, electrically charged soup. This is the wild, chaotic environment where fusion happens. So, how in the world do you get atoms to fuse? Well, here's the problem. At the heart of every hydrogen atom is a positively charged proton. And just like when you try to push the positive ends of two magnets together, these protons naturally push each other apart. The sun's solution? Just brute force. The pressure in its core is 250 times billion times greater than at the bottom of our oceans. It's a force so immense, it just completely overcomes that natural repulsion. This is how it goes down. The process is called the proton-proton chain, and it's responsible for almost all the sun's energy. So first, two protons get crushed together to form a heavier type of hydrogen. Then, that new atom gets slammed by another proton, creating a type of helium. And finally, two of those atoms smash together to create the final stable helium atom we all know. Okay, so hydrogen is becoming helium. That makes sense. But that doesn't really explain the unbelievable amount of energy the sun puts out. I mean, if you're just rearranging the same basic particles, where does all the light and heat actually come from? And here it is. This is the secret. When you weigh that final helium atom, it's actually a tiny bit lighter than the combined weight of all the hydrogen atoms that went into making it. A small amount of mass seems to have just vanished. But it hasn't just disappeared. The explanation lies in what is probably the most famous equation in all of physics, thanks to Albert Einstein. E equals mc squared. So what this equation is telling us is that mass and energy are really just two sides of the same coin. That tiny bit of missing mass from the fusion reaction isn't lost at all. No, it's been converted directly into a pure, massive burst of energy. And that c squared part, the speed of light squared, that's a gigantic number, which means even a teeny tiny speck of mass becomes an enormous amount of energy. And just how much mass are we talking about here? Well, get ready for this. Every single second,
The sun converts 4.3 million tons of its own matter into pure energy.
To even try and wrap your head around that, that's like taking the mass of about 3 million cars, completely vaporizing them and turning them into energy. And that's not per day or per hour, that is happening every single second. That is the power source of our entire solar system. So the energy is created in the core as a particle of light, a photon, but its journey is far from over. In fact, you could say the hardest part is just beginning. Now, it's got to get out. You'd think that photon would just shoot straight out, right? The direct path right to the surface. But the reality is completely different. The sun's core is 20 times denser than iron. So instead of a straight line, the photon starts this chaotic, random walk, bouncing off particles for, well, millennia. You know, scientists have this amazing analogy for this. They say a photon's journey is like trying to walk through a super-packed shopping mall, blindfolded. You take a step, you bump into someone. You get sent off in a totally new direction. You take another step, another collision. You just wander around aimlessly for what would feel like an eternity before you finally found the exit. That's a photon's life inside the sun.
And during this insane journey, the photon is also being transformed. It's born in the core as a super high-energy particle, something like an X-ray, totally invisible to our eyes. But with every single one of those countless collisions over thousands of years, it loses a little bit of energy. It cools down. And by the time it finally reaches the surface, it has become the gentle, visible light that warms our world.
And so that ancient light, born from mass itself in a reaction tens of thousands of years ago, transformed by a chaotic journey through plasma, finally breaks free. It then makes that final quick 8-minute trip across the vacuum of space to our planet, where it fuels literally everything we know. So the next time you feel the sun on your skin, just remember that incredible story it's telling, a story of cosmic recycling, of impossible pressures, and a journey older than all of our recorded history. It really makes you wonder, if the light we see every single day holds a secret this profound, what other cosmic mysteries are out there, just hiding in plain sight?